Today we're going to talk about 5.4, factor and solve polynomial equations. So this type of trinomial is called a general trinomial. And that's because it's not any specific factorable trinomial, but it is factorable. So this is just called a general trinomial. This one is the square of a binomial, so it's a perfect square trinomial. This one ends up being the difference of two squares, so you can factor it like this, with the square root of the first part being the first part in both of these, 1 plus, 1 minus, and the square root of the second part being the second part in each of these. And this is called a difference of two squares. And the last one, these two terms have a common factor in 4x, so we call it a common monomial factor. And it's a monomial because this factor is only one term. Even though it's 4x, it's still only one term. So now we are going to read about factoring polynomials. A factorable polynomial with integer coefficients is factored completely if it is written as a product of unfactorable polynomials with integer coefficients. So integer means a whole number. 1, 2, 3, 4. 0 is also included. And negative numbers are also included. So -1, -2, -3, -4, any of those. So those are integers. Coefficients are what we multiply by our variables. And it has to be unfactorable. Okay, so for example 1, we're determining whether each of the following are factored completely. If not, complete the factorization. So for this one, we look at each part. We don't have any fractions, so we're good there. And we look at each part. So 2 cannot be factored anymore. X plus 1 cannot be factored anymore. And x minus 4 cannot be factored anymore. So this one is completely factored. So we write yes. And we have no more work to do because it is completely factored. For the next one, we look at this and see we don't have any fractions, so we're good there. Then 3x cannot be factored anymore, but x squared minus 4 is a difference of two squares, so we can. So we take the square root of our first number here and we get x, and we take the square root of our second number here and we get 2. So this factored, we've got to keep the 3x there, but then our two parts become the square root of our first part, which is x, and the square root of our second part, which is 2, with a plus in one of them and a minus in the other. Okay, and then the last one, 5x squared and x squared minus 3. So we don't have any fractions, and 5x squared can't be factored anymore. So we look at x squared minus 3. Now, this looks similar to this, but the difference here is that the 3 is not a perfect square. So it's not going to be a pretty number like 2 when we take the square root of it. So this one is completely factored because we'd end up with something that's not an integer if we separated it. Okay. So now, factor the polynomial completely. So our first step whenever we factor is to look and see if we have a common factor. Each of these terms has an x in it, so we're going to factor out the x first. And we're left with x squared plus 2x minus 15. Now we look and see if we can factor what's left in here. So we have to remember back to chapter 4 when we factored, and remember that we need to take the factors of negative 15 that add to 2. So if we think on that for a couple of seconds, we get negative 3 and positive 5. So that means that our big trinomial here factors into x minus 3 and x plus 5. Okay, and now we have 3 parts without fractions or square roots or anything, and none of them can be factored anymore, so we are done. Okay, so part B. We look here. Both of these have y's, and they're both divisible by 2. So we're going to pull out at least 2y. Now, this one has 5 y's, and this one has 3 y's. So we're going to pull out y to the third. So we're left with y squared minus 9. Okay, so if you need to double check, FOIL it back out, or distribute it back out, and make sure that you get this again. Okay, so now we look at this. We have no fractions, no square roots, so we're good there. 2y to the third can't be factored anymore, but y squared minus 9 is a difference of squares. So we take the square root of this one, and we get y. Take the square root of this one, and we get 3, and we have 1 with a plus and 1 with a minus. That's how we factor a difference of squares. So now we look back, we brought this down. 2y to the third still can't be factored anymore. Y plus 3 can't be factored anymore, and y minus 3 can't be factored anymore. So we are done. Now for C. All of these are divisible by 4, and the smallest number of z's that we have is 2, so I'm going to factor out 4z squared, and I'm left with z squared minus 4z plus 4. Again, if you need to distribute that back out to make sure that it's the same as this, go ahead. So we don't have any fractions, no square roots, so we're good there. 4z squared can't be factored anymore. And we need to check if this trinomial here can be factored. So we need to find factors of 4 that add to negative 4. And if we think on that for a second, we get negative 2 and negative 2. So we bring down the 4z squared, and we are left with z minus 2 and z minus 2 once we factor this trinomial here. And we look at this. This cannot be factored anymore. This cannot be factored anymore. And this cannot be factored anymore. So we are finished. Okay, so the last part here is our special factoring patterns. So the sum of two cubes, our formula is a to the third plus b to the third equals a plus b in parentheses times a squared plus ab, no, a squared minus ab plus b squared. Okay, so let's look at an example. Let's say I have x to the third plus 8. Okay, I have to take the cubed root of this. So if a to the third is the same as x to the third, that means that a is equal to x. And b to the third is 8. So we have to think, what to the third power is 8? So 2 times 2 times 2 is 8. So that means b is equal to 2. So now we plug into our formula. So we get x plus 2 times x squared, so a squared, minus 2x, because x times 2 is just 2x, plus 2 squared, which is 4. Okay, this does not factor any smaller, so that's why our formula stops here. Okay, so that is the factored form of this. So now if we have the difference of two cubes, a to the third minus b to the third, our equation changes a little bit. We get a minus b, and then a squared plus ab plus b squared. Okay, so these two signs here just flip. That's the only thing that changed. So now we're going to talk about y to the third minus 27. Okay, so if a to the third is the same as y to the third, that means that a is equal to y. And if b to the third is equal to 27, it means b is equal to 3. Now, it's positive 3 and not negative 3 because we've already factored our negative into the formula. That's already part of it. So we just say 3, not negative 3 here. So we're going to do y minus, because this is a minus, our 3, and then y squared plus 3y plus 9. So we just plugged into our formula and got those answers. So for example 3 here, for part A, we are factoring x to the third plus 64. So this is a sum of cubes. So we are going to use our formula, a to the third plus b to the third equals a plus b, a squared minus ab plus b squared. I'm just copying this off the previous page so that it's easier to reference. So we are going to look to find out what a is. So if a to the third is the same as x to the third, then a is equal to x. And if b to the third is 64, then b is going to be 4, because 4 times 4 is 16, times 4 is 64. So now we just plug in x to the third plus 4 to the third, which is our original equation, just written a little different, equals x plus 4 times x squared minus 4x plus 16, because of 4 squared. Okay, and we are done factoring. That's all we can do. So for part B, this one's a little bit trickier. The first thing we're going to do is factor out any common factors. So, I know that both are divisible by 2, and both have at least z squared. So I'm going to factor out 2z squared. So I'm left with 8z to the third minus 125. Okay, I can't factor anything else out. So now I look at this term. I know I have a z to the third. And if I think about it, 8 is the same as 2 to the third. So this is a cube where a is 2z. Because 2z times 2z times 2z is going to be 8z to the third. And 125 is 5 to the third. 5 times 5 is 25. 5 quarters make $1.25. So here's our a and here's our b. This is a difference of cubes. So a to the third minus b to the third equals a minus b, a squared plus ab plus b squared is our formula. So now we just plug in. So we keep our 2z squared out in front, and then we plug in our a, which is 2z, minus our b, which is 5. Now I think of a squared. So 2z squared is going to be 4z squared, because it's 2z squared. Okay, and then 2z times 5 is 10z, and then b squared is 5 squared, so 25. And that is our answer for that one. Right? And another type of factoring for trinomials or larger, generally for polynomials with 4 parts, is factoring by grouping. So for some polynomials, you can factor by grouping pairs of terms that have a common monomial factor. The pattern for factoring by grouping is RA plus RB plus SA plus SB can be factored. If we look at the first 2 terms, they have a common factor of r. So I'm going to factor out r from the first 2 terms, and I'm left with a plus b. And then I look at the last 2 terms I have here, and they have s in common, so I can factor that out, and I'm left with a plus b. Now we have something times a plus b plus another something times a plus b. So we can rewrite that as our parts outside our parentheses, so r plus s, and then our parenthesis, our common factor, or r plus s times a plus b. So this will make a little bit more sense after we look at an example. Example 4. Factor the polynomial x to the third minus 3x squared minus 16x plus 48. If we look at our first 2 terms, we have an x squared in common. So I'm going to factor that out, and I'm left with x minus 3. Now, I want to factor something out of these 2 terms so that I am left with x minus 3. So if I look at this right now, this is a negative 16x. And I want to factor something out so that I'm just left with x. So I'm going to factor out negative 16. and I'm left with x. If I divide 48 by negative 16, I'm left with negative 3. So, if I look at this now, I can take my parts outside the parentheses. So x squared minus 16 times my common factor in the parentheses here. So x minus 3. And now I look at these. So x squared minus 16 is a difference of squares. So I figure out x squared is x squared. So the square root of this is x. So I'm going to end up with x and x. And then the square root of 16 is 4. And then I put a plus in one and a minus in the other. That's how we factor a difference of squares. And then I keep my x minus 3. So that is this polynomial completely factored. Okay, so the last thing we're going to talk about today is solving polynomial equations. So we have to think back to the zero product property. In words, the zero product property says, if the product of two expressions is 0, then one or both of the expressions equals 0. In algebra, the zero product property says, if A and B are expressions, and A times B equals 0, then A equals 0 or B equals 0. An example of the zero product property is if x plus 5 times x plus 2 equals 0, then either x plus 5 equals 0 or x plus 2 equals 0. So that means x is negative 5 or x is negative 2. Okay, and we're going to use that today to solve polynomials for all of their solutions. So the number of solutions, including real and imaginary solutions, is equal to the degree of our polynomials, which we talked about earlier in chapter 5. So, for example 5a here, find the real number solutions of the equation. So, the degree of this equation is our biggest exponent on x, which is this 5 right here. So our degree is 5. So we should have 5 answers. Now, that includes real and imaginary answers and any repeated answers. So we might only get 3 different answers, but 2 of them are repeated. So first thing we're going to do is factor this. We look for any common factors, and I see that all of these are divisible by 4, and they all have an x. So I'm going to factor out 4x, and I'm left with x to the 4th minus 10x squared plus 9 is equal to 0. So now I look at this, and even though this is a 4th and this is squared, we can still factor this. We just have to remember to keep our x as x squared. So we're looking for factors of 9 that add to negative 10. So negative 1 and negative 9 are our factors. So 4x, because this was to the 4th power, we have to keep this as a squared. So x squared minus 1 and x squared minus 9 equals 0. And then I notice that each of these are a difference of squares, so they're going to factor again. So I get x plus 1, x minus 1, x plus 3, x minus 3 equals 0. So now, to find all 5 of our answers, I have to set each part equal to 0 and solve for x. So 4x equals 0. means x equals 0, because we divide by 4. X plus 1 equals 0 means that x equals negative 1. X minus 1 equals 0 means that x equals 1. X plus 3 equals 0 means that x equals negative 3. And x minus 3 equals 0 means that x equals positive 3. So that means I got 1, 2, 3, 4, 5 answers, which is how many I needed to find. Now for part B, we have to get it equal to 0, otherwise the zero product property doesn't work. So I'm going to subtract my 14x squared, or x to the third, to the other side. So I get 2x to the fifth minus 14x to the third plus 24x. And I just wrote it in descending order of degree to make it easier. So now I look and see what our common factor is. And I notice that all of these are divisible by 2, and all of them have an x. So then I'm left with x to the fourth minus 7x squared plus 12 equals 0. And again, I have an x to the fourth, but my middle term is x squared, so I can factor it. So I look for factors of 12 that add to 7, negative 7. And I get negative 4 and negative 3. So I factor this as x squared minus 4 and x squared minus 3. Now, only this one is a difference of squares, so that's the only one that I can factor more. So x plus 2, x minus 2, and x squared minus 3 stays exactly the same. So now when we set each equal to 0 and solve for x, 2x equals 0 means that x is equal to 0. X plus 2 is equal to 0 means that x equals negative 2. X minus 2 equals 0 means that x is positive 2. And now x squared minus 3 equals 0 is a little bit trickier. What we're going to do is we're going to solve for x. So we move the 3 over. We get x squared equals 3. And then we take the square root of both sides to get x by itself. When we do that, we get a positive or negative square root of 3. So that means that x is either equal to positive root 3 or x is equal to negative root 3. So we still end up with 1, 2, 3, 4, 5 answers. And again, our degree was 5. So that's how many we needed to find. And our last one here. Again, we move this one over. So I get 6x to the fourth minus 27x to the third plus 15x squared equals 0. Now I factor out our common terms. I know everything's divisible by 3. And everything has at least an x squared in it, so I'm going to factor that out. I'm left with 2x squared minus 9x plus 5 equals 0. Now, we have a number in front here, so we have to take a times c, and we get 10. We want two factors of 10 that add to negative 9. We could do negative 10 and 1, but that would multiply to negative 10. So nothing factors like that. So we cannot factor this anymore. So now we set each part equal to 0. 3x squared equals 0. We divide by 3, we get x squared equals 0. Then we take the square root, and we get x equals positive or negative 0. 0 can't be positive or negative. It has no sign, but it happens twice. So we get x equals 0 and x equals 0. Then for this other one, we're going to use the quadratic formula. So x equals negative b. So negative 9 is b. So negative 9 is just 9, plus or minus the square root of negative 9 squared minus 4 times 2 times 5 all over 2 times 2. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that will simplify to x equals 9 plus or minus the square root of 81 minus 40 all over 4. So 9 plus or minus the square root of 41 all over 4. These are not clean numbers, but they are two separate numbers because we get x equals 9 plus the square root of 41 over 4, or x equals 9 minus the square root of 41 over 4. So we get 1, 2, 3, 4 answers, and our degree of our polynomial was 4, so that's how many we needed to get. So these two aren't clean, and 0 happens twice, but we still managed to get all 4 of our answers.